Welcome to how to graph tangents and normals to functions with the fx-CG100. In this video, we will demonstrate how to evaluate the gradient of a function with the derivative, graph tangents and normals, and find their Cartesian equations. To start, we will draw this trig function. Press Home and select Graph and Table by scrolling or using the shortcut. Press Settings. The derivative is turned off by default, so scroll and turn it on with OK. Press back to close the settings pop-up. Enter the function and confirm. Then move to the Graph tab with Right tab. From the View window pop-up, we will change the settings to optimize the graph for our function. Select Preset Windows and Trigonometric. The scales are now more suitable for sin x. Select Draw to sketch the graph. We can now find the gradient of the function at any point. Press Tools to open the pop-up. Select Trace to analyze points on the function. The cursor is placed on the function at the center of the x scale, with both coordinate values below and the coordinates of the point. As the derivative is on, the decimal values for dy dx is also displayed. Move the cursor along the function by scrolling left and right. The step value for each scroll is based on the current x scale and may not lead to a required value. In that case, instead of scrolling, simply enter a value, which opens a pop-up. Then confirm with OK to place the cursor at that point and display the gradient value. Scrolling will move the cursor, or another value can be entered. To end the trace analysis, as before, press back. An alternative method for evaluating functions and derivative values is to use Table. Page scroll up to display the tabs, and Right tab to the Table tab. The table is automatically populated with truncated function and derivative values. For specific x values, enter them in any row of the x column. And confirm. Scroll to highlight individual values to display a full decimal. We can now look at graphing the tangent to a function. Return to the graph by pressing Left tab and Draw. Then press Tools to open the pop-up. Select Sketch by scrolling to the next menu page, or use the shortcut, which may be faster. Select Tangent Line to sketch a tangent to the function at the center of the x scale. Note the coordinate and dy dx values are displayed as for trace. Move the tangent along the function by scrolling left or right. Or enter a specific value if you cannot scroll to it, either directly or as a calculation or stored variable. On confirmation, the tangent is then placed at that point. To view the truncated decimal equation of the tangent, press OK again, and end the analysis with back. The normal to a function can also be drawn. From Tools, select Sketch again, and this time select Normal Line. As before, the normal is placed at the center of the scale. Notice that the displayed gradient is still dy dx and not the negative reciprocal. Scroll or enter a value to move the normal. Confirm to place the normal at that point. And press OK to display the equation of the normal. Then end the analysis with back. Unfortunately, the normal and tangent do not appear to be perpendicular to each other, which is misleading. This is because of the scales used. To achieve a more accurate sketch, we need to square the scales. From Tools, select View Window and Preset Windows. Both Initialize and Standard are square scales and so could be used. However, to retain the best shape for this trig function, select Square. The scales can now be squared based on either the current X or Y scales. Select X base to return to the View Window pop-up. Close it with Back and redraw. The scales now have a 1:1 ratio and the normal will be sketched perpendicular to the tangent line. To find the equation of the tangent or normal exactly, it is useful to differentiate numerically. From Home, select Calculate. For the gradient of the normal, enter the negative reciprocal using the fraction template. To use the differentiation template, press Catalog and select Function Analysis. Then select the first derivative d dx. This opens a template where the function and x values can be entered. Either enter the function directly as sin x, or to reduce possibility of input error for a more complicated function, press Variable. We can now recall and use any stored variables, functions or lists. Select Function to display the stored functions, and select the sin x function, which is y1. This enters the function in the template using the graph notation. Then scroll and enter the coordinate value directly as a calculation or a stored variable. Executing displays the exact gradient of the normal at that point. Tangents and normals can also be sketched for other types of function, such as parametric equations. Please refer to our other videos for details of how to enter parametric equations. From Home, go to Graph&Table, change the type of function entered, and then enter the two equations. Notice that the variable defaults to t. Right tab to open the View Window pop-up. To ensure a complete graph is drawn, scroll and enter a value for the t theta minimum. Then confirm. And go back to the Function tab. Right tab to Graph and select Draw. Finding the gradient of parametric equations uses a similar method to that seen earlier. From Tools, select Trace. The cursor is placed at the lower t bound, displaying three differential values, dx dt, dy dt, and their fraction dy dx. Enter a t value as before, and confirm to place the cursor at that point. Scrolling will also move the cursor. End the analysis with Back. Once entered in Function, it is easy to evaluate multiple points using Table. The table displays both coordinate values and the three derivative values. For specific evaluation for t, enter a new value in any row and confirm. Sketching the tangent to a parametric equation follows the same method as before. First, tab left to Graph, then draw the function. From Tools, select Sketch and Tangent Line. Scroll or enter a value and confirm to place the tangent where you want it. The tangent is drawn together with the display showing the three derivative values. Press OK to show the Cartesian equation of the tangent, with truncated decimal values. Normals can also be sketched as before. We hope that you found this video useful. If so, please do check out our other resources on the Casio Education UK website and YouTube.